Solar Storm of 2024. The auroral displays that wowed observers around the world 2 weekends ago, including folks as far south as Florida in the US and Ladakh in northern India, may have been among the strongest such light shows since record-keeping began. With reports of auroras visible to as low as 26 degrees magnetic latitude, this recent storm may compete with some of the lowest latitude aurora sightings on record over the past 5 centuries. Though scientists are still assessing this ranking, NASA officials stated that it's a little hard to gauge storms over time because our technology is always changing. Aurora visibility is not the perfect measure, but it allows us to compare over centuries. The northern and southern lights are usually a spectacle only in high-latitude areas, such as the Arctic and northern Canada. But the vivid colors migrated toward the equator on May 10 because of a rare G5 geomagnetic storm unleashed by our hyperactive sun a few days prior, the strongest to hit our planet since Halloween of 2003. Between May 3 and May 9, NASA's Solar Dynamics Observatory cataloged 82 notable solar flares spawning from 2 active regions on the Sun, numbered 3D 663 and 3D 664. These clusters of sunspots grew so complex that they erupted repeatedly during the week. Starting on May 7, at least 7 coronal mass ejections, or CMES, charged toward Earth and began storming our planet on May 10, which was when the strongest auroras were seen. The CMES all arrived largely at once, and the conditions were just right to create a really historic storm. Elizabeth McDonald, a space physicist at NASA's Goddard Space Flight Center in Maryland, mentioned that this storm was so intense that the U.S. National Oceanic and Atmospheric Administration, which forecasts solar storms and their impact on our planet, issued a storm warning for the first time in nearly 2 decades. The warning prompted NASA to preemptively put at least one of its satellites, ISAT-2, into safe mode. Certain instruments on board other missions were also powered down, the space agency noted in the statement. To better understand the full extent of the event, scientists are also studying reports submitted by citizen scientists to the NASA-funded effort known as Aurorasaurus, which tracks auroras around the world. Aurora-related tweets and reports are aggregated into a map and verified with the help of citizen scientists, according to the website. Each verified report then becomes a data point for scientists to study and potentially incorporate into space weather models. We'll be studying this event for years. Teresa Neves Chinchilla, acting director of NASA's Moon to Mars Space Weather Analysis Office, stated that this event will help us test the limits of our models and understanding of solar storms. The cluster of sunspots that sparked the historic dazzling display of lights has rotated out of our view, thanks to the sun's spin. However, scientists say it is now coming into view of Mars, which has already begun witnessing the impacts of our 3D 664's strongest flare yet, which was fired off last Tuesday, May 14. We're already starting to capture some data at Mars, so this story only continues. May 2024 has already proven to be a particularly stormy month for our Sun. During the first full week of May, a barrage of large solar flares and coronal mass ejections, CMES, launched clouds of charged particles and magnetic fields toward Earth, creating the strongest solar storm to reach Earth in 2 decades, and possibly one of the strongest displays of auroras on record in the past 500 years. From May 3 through May 9, 2024, NASA's Solar Dynamics Observatory observed 82 notable solar flares. The flares came mainly from 2 active regions on the Sun called R13-663 and R13-664. This video highlights all flares classified at M5 or higher, with 9 categorized as X-class solar flares. The first signs of the solar storm started late on May 7 with 2 strong solar flares. From May 7-11, multiple strong solar flares and at least 7 CMES stormed toward Earth. 8 of the flares in this period were the most powerful type, known as X-class, with the strongest peaking with a rating of X58. Since then, the same solar region has released many more large flares, including an X87 flare, the most powerful flare seen this solar cycle on May 14. Traveling at speeds up to 3 million mph, the CMS bunched up in waves that reached Earth starting May 10, creating a long-lasting geomagnetic storm that reached a rating of G5, the highest level on the geomagnetic storm scale, and one that hasn't been seen since 2003. The CMS all arrived largely at once, and the conditions were just right to create a really historic storm, said Elizabeth McDonald, NASA heliophysics citizen science lead and a space scientist at NASA's Goddard Space Flight Center in Greenbelt, Maryland. When the storm reached Earth, it created brilliant auroras seen around the globe. Auroras were even visible at unusually low latitudes, including the southern U.S. and northern India. The strongest auroras were seen the night of May 10, and they continued to illuminate night skies throughout the weekend. Thousands of reports submitted to the NASA-funded Aurorasaurus citizen science site are helping scientists study the event to learn more about auroras. Cameras, even standard cell phone cameras, are much more sensitive to the colors of the aurora than they were in the past, McDonald said. By collecting photos from around the world, we have a huge opportunity to learn more about auroras through citizen science. By one measure of geomagnetic storm strength, called the Disturbance Storm Time Index, which dates back to 1957. This storm was similar to historic storms in 1958 and 23. And with reports of auroras visible to as low as 26 degrees magnetic latitude, this recent storm may compete with some of the lowest latitude aurora sightings on record over the past 5 centuries. Though scientists are still assessing this ranking, it's a little hard to gauge storms over time because our technology is always changing, said Dolores Knipp, a research professor in the Smead Aerospace Engineering Science Department and a senior research associate at the NCAR High Altitude Observatory in Boulder, Colorado. Aurora visibility is not the perfect measure, but it allows us to compare over centuries. McDonald encourages people to continue submitting aurora reports to Aurorasaurus.org, noting that even non-sightings are valuable for helping scientists understand the extent of the event. Leading up to the storm, the National Oceanic and Atmospheric Administration Space Weather Prediction Center, which is responsible for forecasting solar storm impacts, sent notifications to operators of power grids and commercial satellites to help them mitigate potential impacts. Warnings helped many NASA missions brace for the storm, with some spacecraft preemptively powering down certain instruments or systems to avoid issues. NASA's ICEAT-2, which studies polar ice sheets, entered safe mode. Stay tuned for more fascinating insights and updates. Thanks for watching, and don't forget to subscribe to InfoBurst for more intriguing content.